Hello, and thank you for joining us. My name is Randy Reed. I'm the editor and publisher of the Edison Report. Today I have the honor of once again moderating the annual Lighting Forum, sponsored by the National Lighting Bureau and co-sponsored by the Edison Report and the International Brotherhood of Electrical Workers, the IBEW, which so graciously lends us its production facilities and personnel to help make this event so special every year. The panel I'm about to convene will give us an update on the Internet of Things and cybersecurity, specifically as they interrelate with lighting. Our two panelists are eminently qualified to address these topics. They are Mark Lien, Industry Relations Manager of the Illuminating Engineering Society, and Chris Yorgey, an Engineering Project Leader with Lutron Electronics. Gentlemen, welcome.
Thank you. Thank you.
And Chris, the first question goes to you. What is the state of the IoT with regards to the lighting industry?
Right. I think that's a great question. One of the places that we like to start off with when answering a question like that is, what does IoT really mean? There's a lot of different definitions that people use for IoT. I've gotten the question, when will your sensor be IoT? What does that question really mean? And so when we talk about IoT at Lutron, one of the things we talk about is we have commonized our own definition. Across the industry, there's kind of different definitions that people will use, but for us, what we define it as is products and services that connect to one another and share data to deliver value. And so that's a very broad brush stroke definition. And so there's a lot of different categories that fit under there and applications. And I think that's really when people ask the question of when will you have an IoT sensor or occupancy sensor, if you dig down into that question, what they're really asking is, well, when will you have a sensor that can talk to both lighting and HVAC and maybe security? I want a single sensor that does all of that. And that's really what the questions revolve around, is applications. So to answer the question of how penetrated IoT is into the lighting industry, you really have to look at specific applications. So for example, in the lighting world, we've actually had IoT technology under that definition for a long time. Protocols like DALI have allowed us to individually address and speak to fixtures. So there we're fairly well penetrated. If you look though at other technologies, we're just sort of starting to scratch the surface.
Yeah, Chris brings up a very good point. How we define IoT really affects your question, affects the answer. We don't have an ANSI definition for Internet of Things. We've just recently had some ANSI definitions for the C-137 Committee on Lighting Systems, and they talk about interchangeability, interoperability, so we have American national standards for that terminology. For IoT, individual companies are coming up with their own definitions, and even the analytic companies, the people like McKinsey and Navigant, Forbes magazine recently had a study of what the market projections were for IoT, and they ranged from hundreds of millions to trillions of dollars. And the reason is because they all defined the scope differently.
Sure.
There's a process that I have applied to solid state lighting that comes from a book called Bold by Peter Diamandis. And he talks about any technology that goes digital goes through 6 sequential steps. And the first step is it goes digital, which means that it's going to be easy to disseminate quickly and cheaply. And of course our apps are all digital. IoT is primarily digital. Then it goes into a period of deception. And that's the period where the hype is there. The Gartner Analytics Group calls it the hype cycle. But that's the period where the promises are being made, and we hear about all the great things that this technology can do, but they haven't materialized yet. And what happens is we get disillusioned, and the reason for it can be expressed, I think, well with an example from computers or robots. With computers, we heard about all the great things they were going to do. In fact, you're working 1 day a week now, right?
No.
Because computers have given you so much free time?
I'm working 6 days a week.
Okay, well it promised us that, right? And also promised us that there'd be computers work in our cars and our homes, and that's starting to happen. But initially, when we first got computers, we had a big plastic box that played Pong, and that's very anticlimactic. Robots were the same way. We saw science fiction. We saw Rosie the robot in a cartoon on TV. They were in our homes talking to us. They had personalities. And what we got, and our first experience with robots was a Roomba vacuum cleaner. Also very disillusioning. With LEDs, it was similar. Now, this book never mentions LEDs, but the pattern follows the same. With LEDs, the first ones were not bright enough, they weren't efficient, the colors were awful, there was no consistency, you couldn't dim them. Just a disaster compared to everybody telling us this was the future, right? So people get disillusioned and they sit back and they go, I'm not sure about this. And the product doesn't achieve a quick market penetration. But once the early adopters get past that stage, economies of scale kick in, it moves into an exponential growth curve, and the next step is disruption.
Okay.
And it disrupts the industry. Then there's demonetization. Things get cheaper and cheaper, like we've seen with solid state lighting. Then there's dematerialization. And what happens there is they get smaller and smaller. I just went to a conference on nanotechnology and nanoplasmatics. This is tiny stuff, billions of a meter scale, right? With LEDs, we see the same thing happening. We have LEDs that are 3 atoms thick. They can print out of inkjet cartridges. Tiny blood cells is the size of some of these LEDs. The scale gets smaller until they almost disappear into the electrical infrastructure of the building. The last step of these 6 sequential steps is democratization, and that is when everything becomes ubiquitous and cheap enough that everybody has it. With solid state lighting, we're already past demonetization, and we're hitting into dematerialization. Things are getting smaller and integrated into other devices like IoT. With IoT, we're still in that period of deception, and that's why market penetration has been so slow. But when it takes off, it will go quickly.
Okay, so let's discuss that. Because why is the penetration so slow? Given all the great media coverage that we've had, it really is.
But it's true of all of these kind of technologies. Early stages, you have people that are early adopters, and they've got the money to buy in. And it takes time until there's enough awareness of the potential of these, until there is the economies of scale with a number of companies being involved to get this going. And that hasn't happened yet with IoT. As a matter of fact, the IoT conferences that I go to, they don't even talk lighting yet. They don't know how we fit.
Really?
Yeah.
That's surprising.
I think that's a key component, is that basically the cost-benefit analysis. Homeowners and building occupants, building owners are doing that analysis, and they're just not finding the value to be there yet. I think some of the things that Mark's talking about are starting to happen, though. If you look at voice assistants like Alexa and Amazon Alexa and Google Home, you have disruption happening where people buy these products and they think, oh, this is great. What can I connect to this to control my home? And lighting is a natural extension, so we're seeing a very big uptick in interest there from the general population.
Yeah, there's a disconnect also in terms, and you mentioned consumers aren't finding the value. Well, there's a big disconnect on what consumers want. The CABA, the Continental Automated Building Association, they did a study last year where they interviewed manufacturers about the products that they were making for IoT, and they asked them what features and benefits that they were building in that their customers wanted. Then they went to the customers and they asked them, what do you want? And it was clear that a lot of these manufacturers are working in isolation, because what these customers wanted, the number one, just far and above any other consideration, was saving energy, saving money.
Okay.
But that isn't what the manufacturers were looking to give them. There were all kinds of non-energy benefits that were coming from the products that they were making. So the consumers are disconnected from that. They're not seeing the value. And energy savings, once somebody switched to LED, that energy savings isn't going to be a good ROI anymore.
Right. So Chris, but back to the lack of penetration. Could security be an issue? People concerned about security?
I think it certainly could. I mean, every day we hear news stories coming out in the news and media about, this product was hacked, that product was hacked. A botnet takes down the internet in the Northeast. I think these stories are starting to fear consumers, cause fear and scare them away in some cases. So I think it's our job as industry professionals to make sure our products are robust and we can quell those fears and address those fears.
You know, we're seeing a lot of concerns about many different aspects of the security of this. You know, you're looking right now at a device, Randy, that has a camera in it, and people can turn that camera on and that microphone on without you knowing it. So companies are making products that cover the camera on the device, right? Because we're concerned about that. We're certainly concerned about things like the botnet that you talked about and the denial of service attacks and such things that have happened even with lighting, where lighting has been employed to ping URLs until the websites crash, and they even brought down Amazon temporarily last year. And lighting was part of that attack. Those are all very, very valid concerns, but I don't know that there's enough market penetration now that that's what's slowing it. Ultimately, if we're the weakest link in lighting, though, it will have a very detrimental effect, and it could slow progress of IoT.
You see mass adoption occurring in residential first or commercial?
It's happening concurrently, but in very different ways. So in residential, we see the voice activation being dominant. There's some movement with voice activation into specific commercial areas, but that looks like the near future for residential. To connect all the devices through voice activation, Alexa, Google Home, those kind of devices. For commercial, we see smart cities really paving the way, utilizing the protocols, testing the sensors that ultimately will inform how interior spaces evolve.
Okay.
And also in the commercial space, what you're seeing in new construction at least is energy codes are sort of making a push on this technology. So on the residential side, you have the Alexas and Googles and the interest in that causing a pull on the technology, but energy codes are kind of doing a push. So for example, Title 24, 2019 is going to require Open ADR, which is effectively an IoT protocol. It's an IoT standard where utilities can reach into buildings and tell them that they need to reduce their demand. That's technology being pushed into the commercial applications. And so they're both developing in parallel, but in different ways, very different ways, like Mark mentioned.
Yeah, and it's really sounds very progressive for Title 24, which has been progressive, and I appreciate what they do. But at the same time, we've seen limitations because the technology shift that they haven't anticipated has caused these limitations. Title 20, for example, they put a standby power limit in place in 2016 that I believe was 1/2 a watt. And these devices, if it's a lighting fixture with multiple sensors in it that provides many functions other than lighting, their standby power is going to be much higher. I bought one light product. It was like an R20 screw-in lamp that had a video camera in. It had live Wi-Fi streaming. It also recorded onto an SD card. It had infrared built into it with the LEDs, so it was visible in darkness, a real covert device, if you will, and a motion sensor, so it only turned on when someone comes into the space, right? It was 2.4 watts standby power. So when you combine these technologies, and part of it was lighting, it no longer met the code.
Right.
And the codes have to be modified, and it's easy to do. They just say, you know, for an infrared sensor, you're allowed 1/4 of a watt for, you know, so it could be incremental.
Be additive.
But it hasn't happened yet because this is new technology moving into our area.
So what protocols are safe?
So there is no safe protocol per se. Many of the protocols out there have security mechanisms built into them that offer means to secure the protocol, but it all depends on how the implementation is done. There's some great examples out there. So Philips Hue is an excellently designed product, a very well designed product, but there was vulnerabilities found in it where hackers were able to get in and compromise the firmware of that device. It used a Zigbee security protocol that was implemented at the time, but the hackers found a vulnerability in that protocol. So really what it comes down to is security is all about an arms race. And as manufacturers, you have to stay constantly on top of what's the latest hacker doing? You know, what are the new vulnerabilities that are being exposed? Making sure that you're closing the floodgate and not allowing those vulnerabilities to proliferate and you know, putting out patches appropriately. So you really need a strategy in place as a manufacturer to continually plan to upgrade these products to account for all the new vulnerabilities that come out.
And you mentioned Zigbee, and you can do a great illustration from Zigbee. This is the backbone of a number of things, including some of the new Amazon Echo products and the Philips Hue lamp and many others. And as a protocol, it's excellent, and it has the capability of being very secure. With Zigbee, you can build in multiple passwords, for example. The problem is manufacturers don't want to employ multiple passwords because it compromises the user experience.
Right.
It would make it safer, but if somebody else doesn't use it, then they have a competitive advantage, so they don't do it. So
Right.
In many cases, the ability to make these things more secure exists, but the trade-off isn't acceptable.
We talk a lot about hacking and security. Can Li-Fi help with this?
I've heard a lot about the potential for Li-Fi to create a more secure network between your device and the building network. To me personally, I think there's actually more risks, because if you're transmitting data through pulse width modulation of light, if that light, wherever that light can go, that data also can go with it. So if you're looking through a window and I can see that light well enough, then there's the potential that I could be receiving the data that's coming through that light. So I think personally there's like any technology, there's risks associated with the rewards. And so we just have to understand what those risks are and how they can be mitigated.
But wouldn't it be safer than Wi-Fi, which we know will penetrate the building and the walls? Right?
Yep, I think either way. I mean, most commercial constructions are fundamentally metallic, so we actually know that RF doesn't penetrate those too well. So there's protection we can put in place for that. There's probably protection we can put in place for Li-Fi as well. But certainly, again, there's risks and rewards either way.
Yeah, I haven't seen an example of Li-Fi's security concerns, but part of that is because it's relatively new technology. I mean, we see much more of it in Europe than we do here. But as it becomes more plentiful, like Apple's computers, initially we were just talking about this, they said, we don't have any viruses. Well, they were only 8% of the market share.
Right.
As the market share increases, then they became vulnerable to more attacks. So with Li-Fi, the precedent is that there isn't a single protocol that I'm aware of, and please correct me, Chris, if there's not a single protocol that's been used for lighting that hasn't been hacked.
You know, you mentioned those 6 schemes early on.
The 6 sequential steps, 6
sequential
Ds.
steps. I would say Li-Fi is in that second one, where it's hype.
Yeah.
It's a lot of talk, but it still hasn't really proven itself.
I was presenting earlier this year in Tel Aviv, and the presenter that came on after me was from a Li-Fi manufacturer in Switzerland, and they're in 2nd generation on the product lines with Li-Fi, and it's pretty impressive. But here, I'd have to totally agree with you. It's in that deception stage.
Mark, you recently attended a conference that focused on autonomous vehicles. Was there any discussion about vehicle-to-vehicle communication using light?
There were discussions about vehicle-to-vehicle communication, but not using LiDAR.
Sure, which is
Yeah,
laser based
as a matter of
on
fact,
light.
they had one of the vehicles there with the LiDAR devices on the top.
What exciting things did you learn at this conference that would affect our industry?
Well, there's some that would affect our industry. LiDAR is an interesting technology, too. I'm not sure, other than autonomous vehicles, how that's going to play out, to have these lasers sending multiple signals at high speed to determine distances and shapes and things. From our industry standpoint, in terms of autonomous vehicles, it doesn't appear that there's going to be any need for expressway lighting, for example. You'll still have concerns with safety in cities and where there are intersections, but expressway and long stretches of roadway in autonomous vehicles, ultimately we won't need it. There'll be a transition period that'll take quite a bit of time till we get there, but ultimately that goes away.
But still you have headlights.
Well, potentially, but they were talking about some vehicles won't even need the headlights, because why would you?
Because I would freak out as a passenger driving 60 miles an hour with no light.
That's the concern, is the human experience. And that even prompted one person when I asked this question, one of the panelists talking about this, to say, you know, some people might want to see what's going on around them. And that's a possibility. But if you think about it, subways, you don't really have much of a visual field on a subway either, and we accept that.
Interesting.
You know, money will rule here.
Right, like it always does.
Like it always does.
Okay. Closing comments?
So I think for us, one of the things we like to focus on is the concept of understanding risk versus reward. And if we can mitigate the impacts of compromising a system, I think long term that's an important part of the strategy. So obviously we need to secure our systems as much as possible, but beyond that we need to understand what are the implications if a system is compromised. And so when you're designing the security of a building and the security of a system that's going to go into a building, it's important to understand both how can you secure it, and then when it's compromised, what are the impacts and how do you mitigate those impacts. And so to mitigate the impacts, we take a technology called designing around non-propagation of attacks. So if something is compromised, like that dolly example, if I compromise the fixture, how do I design my system or my building in a way where that doesn't mean that I can get further downstream? And so I think that's going to be a critical component, is how do we design these systems and products in a way that compromising one thing doesn't mean the whole world's
Like the
open up to
Target
us.
situation.
Like the Target, yep, exactly.
Mark?
So Cisco said years ago that, and about 3 years ago, they said we're 1% into the Internet of Things, based on the amount of devices that are currently in use compared to what they anticipate ultimately to be used. That's pretty startling if you think about it in terms of the potential. One futurist that I follow said that there'll be more wealth created in the next 10 years than the past 100 based on these changes. And we're in a point in time where we know IoT is coming. We're only single digits into the transformation, whatever that number may be, it's low. And there's a lot of people that are going to benefit from this. Exactly how you and what you want to invest your money in isn't entirely clear yet, but what is clear is that the lighting community is going to change dramatically in this process. It would seem that the adjacent industries that really didn't involve us now are converging. We actually have 8 major tech fields right now that are converging. As a result, there's a lot of unexpected convergent consequences that are going to generate a lot of this profit. The lighting industry needs to be very concerned about maintaining the quality of the lighted environment. And we need to understand these changes, and people who understand them need to get involved. And that's where I would ask that anyone who has expertise in these areas that are converging in lighting, contact me. We'll get you on a committee. Let's get involved and change it for the better.
Right. Okay. Well, gentlemen, thank you.